will talk about references and borrowing. Okay, so what is a reference? So reference is basically a pointer. A pointer is basically an address. So what is the difference between data and pointer? So data means it contains the actual data of what you have. For example, for a string hello world is the data. Now, what is a pointer to this data? Pointer to this data means it is an address to the memory location where it is actually stored. Okay, it is an address to the memory location where the data is actually stored. Now, you can access the data in two ways. By actually having the data itself and by having the address in which it is stored. So, if you have the address, then you can go there and then take the contents, right? That is the idea. Okay, so that is a reference or a pointer that allows us to access a data that is stored at the address owned by some other variable. I'll show you that example so that it will be more clear. The previous problem, what happened? So if you just change this to println the string inside my function is s. Now what happens? I created a string s. I passed it to this. I don't want to reassign. Okay. So I passed it to this function and then I'm trying to access the string s. But this is not possible because the ownership has been passed to this particular function, right? So this was the issue or the compilation error that we had before. Now, how to solve this problem in a less expensive way? The first method is to create a reference of s and pass the reference of s to the display string. Now, what is happening in real time is you are not actually passing the entire contents of s to the function. Rather, you are passing the address to that string into the function. So the ownership of the string still remains in the memory location with the s, and you're just accessing it with the function by using the address. So you're actually going to that particular memory location and then you are accessing the data. So when you place an ampersand sign before a particular variable, that means the pointer to that variable. For those who are actually familiar with C programming or C++ programming, you might be really good or will be understanding what is an pointer. For those people who are actually programmed using Java or Python, you might not be knowing what is a pointer, but pointer is basically an address to a particular variable. And when you place an ampersand sign before a variable, it actually points to the address of the variable. Okay, so we are trying to access the memory location where s is stored. Let's try to compile this program this time. And what is the error? The error states string. Yeah. So the data type needs to be changed. Okay. So now we are not receiving a string, but rather we are receiving an pointer to string. Okay, now try to compile. Yeah, it works. Let's execute. So when I execute the program, what happens? So it prints twice time, right? So it is the similar result that we got while we use the clone, but clone is an expensive operation. Why? Because we are actually entirely copying the memory location, or sorry, the contents, and then we are going to pass it to a new variable. And an easier method would be to pass the reference rather than passing the value all by itself. Okay, I think the idea is clear. The idea is to just keep a reference, that is to place an ampersand. Now, the main thing that you need to be sure is when you pass an ampersand s, you are actually not passing the value of the string itself. You're passing the address to the same. So you need to change the function definition. You need to change it to the data type and string so that it accepts an and string and not the string. Okay, so there is something called as referencing. This is referencing. And there is something called as dereferencing. Dereferencing means to use a star in the place of ampersand. Now, what is dereferencing? So dereferencing means you are actually going to take the value at the particular location. Okay, this is referencing. I think that is the idea of references. We have discussed about the clone function. We have also discussed about the passing it as, wait, this is ownership, right? We should take this. Yeah. So Yeah. So what I've already shown you is an example of a normal pointer or a normal reference. Okay. Now what if I can use it to change the string? So let mute s and display string and s. And then rather than printing this, I am going to change its value like, okay, low s dot push str. This is to append a particular string. Hi everyone. Okay. And now let's see. Okay, there is an error. Oh yeah, now we need to change this data type to and mute string. Okay. So once you change this to this, now this is a data type. I want a mutable reference. So once I create a mutable reference, now this works really well. And when I execute, this is fun. Okay. So when I execute, you can see the string in the main function is hello world, hi everyone, right? So if I place a space here, it is more readable. Okay. So guys, what happens is I am going to create a string s and I'm going to place it as mutable so that I can change it in the future. First point. The second point is I am going to pass an and mute s. Now what is this and mute s? This means it is a mutable reference. That means the reference or the address can be used in order to change the value that is being holded by the variable. Okay. So you can use the pointer to actually change the value in the memory location. That is the idea of having a mutable reference. Now, when you come to the function, you need to change the data type to and mute string because you are passing an and mute string and not a string. And now what I did was s dot push str. Hi everyone. Now this push str is a function that is used to concatenate or to push or to append another string to the existing string. Okay. So that is the idea, to append a string to the existing string. Now you might have seen similar like functions in Python, extend and strcat in C, etc. So this is the similar function in Rust is to have a push str function. Okay. Now what happens when I execute, when I compile and when I execute, what happens is now I am going to try to access the s in my main function. But what happened is when I call this function, I've already changed its value to hi everyone has been pushed into the string so that my current s value will be hello world, hi everyone, right? That would be the step because I have already changed it in the memory. So the string value has been changed in direct memory by using a mutable reference. I think the idea is clear. Okay. So that is the stuff about mutable reference. And that is something that we have discussed right now. Now, what if I can have, see, in this example, if you see, this is an immutable reference. That means this reference is not used to change the value of s. So simple reference, and s. And s is again used. So how many, you can have many number of and s. Why? Because these things cannot change the value of the variable. Okay. So these are immutable reference. So immutable reference cannot be used to change a value of a variable which is present in memory. But then I'm going to create an mutable reference after these things. So when I create a mutable reference R3 to this, the issue is now I have R1 and R2 pointing to what? See, I'll show this example so that it could be more easily clear. Okay, I'll just come to here and we don't want this. Okay, we have created two references. These are like immutable reference, and this one is actually a mutable reference. Okay, so now I create a mutable reference. Now let's see the execution. So we only have a warning because we have actually used, now see, I have created two different immutable reference and I have used it here, right? What if I just remove this use case? And now I create an immutable reference and then I'm going to print the value using the mutable reference, and then I'm going to print the values in the mutable reference. Okay. Now when I try to compile, you can see that it states this wait, this no problem, and this is on by default. So I think wait, I'll just pass this to the upside, and then I'll try to access this one. Yeah, so now you can see the error. Okay, the idea is I have initially created a mutable reference, and now it says mutable borrow occurs here. So once you actually took a mutable borrow, that means a pointer who can actually change the value of the stuff in memory, and then you cannot have some immutable borrows. Now, why you cannot have some immutable borrow? Because when you have an immutable borrow, that means you are actually using this immutable borrow to see what is the value of the variable in memory. Whereas a mutable borrow is being used in order to change its value. Now, when you have a powerful tool like a mutable variable to change its value, meanwhile, you cannot have these immutable borrows because this mutable reference can change its value in memory, and this R1 and R2, which is actually the immutable references, cannot actually see the change. Okay, so Rust will prevent this. Now, the idea can be shown in a simple XY diagram that I will show you. So X is a mutable reference that is pointing to a content A, and Y is an immutable reference that is pointing to the content A. Okay, so this is immutable and this is mutable. So now Y will contain A and X will also contain A. Now I am going to use this X to change A to A plus 1. Now what happens? Now what happens when I try to access B, access Y? So when I try to access Y, the issue is Y is actually pointing to A, right? But now we have changed the value of A. But this won't be like known by Y because you have got an mutable reference initially. So once you have a mutable reference, then you need to use that mutable reference to make the change, and then only you are able to create immutable references to the same variable. Okay, these things could be really hard to understand because of the idea of referencing. First, this is actually memory management, different kinds of ways to access the memory. So once you have a mutable reference, you need to use it before creating any other uh, reference. Okay, we have talked about reference. We have talked about borrowing. Borrowing is the same effect of referencing. Borrowing means to use reference to actually access the data from the memory. So ampersand represent the references. They allow you to refer to some value without taking the ownership of it. Okay, so we are not taking the ownership. We are just taking the reference, or we are borrowing. This is the method that I was explaining in the beginning of the session. That is, it uses a borrow checker. Now, because it does not own it, the valid points will not depend or will not be dropped when the reference stops being used. So that is why there was no issue when we actually passed it to a function. Okay, mutable reference. We use the mutable reference to actually change. So mutable reference have one big restriction. If you have a mutable reference to a value, you can have no other references to that value until you have used the mutable reference completely. So the restriction is preventing multiple mutable reference to access the same data at the same time. Which, see, the issue is data race, or it can is multiple pointer can be used to edit the same data, which is possible in different languages like C and C++. You can actually take multiple references to a particular kind of data, and this is prevented using some other mechanisms like logs and semaphores. These are stuff that you might learn if you are a CS student and obviously been learning operating systems, compilers, etc. Then you might know about these things, about logs and semaphores, but it's not really relevant. The idea is to just keep in mind that once you have a mutable reference, then you need to use it before taking any other kind of reference. Okay. So the benefit of having this restriction is Rust can prevent data race at compile time. Okay, a data race is similar to the race condition that happens, and when two or more pointers try to access the same data at the same time. at least one of the pointers is being used to write the data, or there is no. So these are some things that you can actually consider. So we also cannot have a mutable reference while we have an immutable one to the same value. Along the questions. The question number 1 is, which of the following symbol is used to describe a reference in Rust? The option 1 is an ampersand, then we have a star, then we have a percentage, and then we have a dollar sign. The second question is, state whether true or false we can have mutable reference while we have an immutable one to the same value. Option A, true. Option B is false. Take your time, think over what has been said, and answer wisely. I'm sharing the results with you. The first question was, which of the following symbol is used to describe a reference in Rust? And the answer was the ampersand symbol. The second question was, state whether true or false we can have a mutable reference while we have an immutable one to the same value. The answer is false. This is actually a tricky question. You need to think it again and again to make sure that you get the right answer. Okay.